All right, we are ready for our last section in chapter 3. This is about the slopes of parallel and perpendicular lines. So we're going to start by finding slopes of a couple lines and then getting into what that means about them. On your papers, I know it's kind of hard to read some of these points, so I'll be sure to write them out before we start working. So to start off with, we've got two lines here. We've got point A at 1, 3, B at 4, 9, C at 4, 2, and D at 7, 8. And we want to find the slopes of both of these lines. We're just going to plug it into slope formula. So the slope of line AB is going to be 9 minus 3 over 4 minus 1. So that would be 6 over 3, so the slope of that line is 2. The slope of CD will be 8 minus 2 over 7 minus 4. That will also give us 6 over 3, so that slope is also 2. So if we look at these two lines, they are parallel lines. They go on forever without ever intersecting, but they're flat in a plane. And by looking at their slopes, we can make the conclusion that two non-vertical lines are parallel if their slopes are equal. 2 and 2 are equal, so their slopes are equal, so they're parallel. Now, this says that there have to be non-vertical lines, and that's because vertical lines have an undefined slope. So we have to have an extra condition here that says any two vertical lines are parallel, because undefined is the same as undefined, but we can't say they're equal because those aren't actually numbers. So we have to have that extra condition, vertical lines are parallel. So here we want to write the equation of the line that is parallel to y equals negative 3x minus 5 and goes to the point negative 1, 8. Now this is very much like what we did last time, where we just wrote equations of lines based on some other information. And here we're given a line and we know we're parallel to it, so we know that our slope will be the same. So our slope is going to be negative 3. Just like we did before, we'll plug in m, y, and x in order to find b, and then we'll write our equation. So 8 equals negative 3 times negative 1 plus b. 8 equals positive 3 plus b, so b is 5. So now we have a slope, we have a y-intercept, we can write our equation. Y equals negative 3x plus 5. For part B, we want to know if these lines are parallel, so we need to find the slope for each line to determine whether they're parallel. These are in standard form, and there is another way to find slope if you're in standard form, but just to keep it consistent, we're just going to get y by itself, and then we can see the slope easily. So on this first one, if we move 3x to the other side, we get negative y equals negative 3x plus 6. Divide both sides by negative 1, so y equals 3x minus 6. Our slope is 3. For the second one, we'll add 6x to both sides, so we get 2y equals 6x plus 24. Divide both sides by 2, so y is 3x plus 12. So our slope again is 3. Those are equal, so the lines are parallel. So, bottom line, parallel lines have the same slope. Now looking at these lines are perpendicular, so now let's look at their slopes and see what happens. So the slope of AB is the same line we saw before. So we'll have 9 minus 3 over 4 minus 1, 6 over 3, so our slope there is still 2. For CD, C is the 0.17, D is 5.5. So the slope of CD in this example is going to be 5 minus 7 over 5 minus 1. That will be negative 2 over 4. When we reduce that, that gives us negative 1/2. And like we said, these are perpendicular lines. And what do you notice about their slopes? They're not equal, obviously. But notice that if we flip 2 upside down, if we find the reciprocal of 2, we get 1/2. And then if we change the sign on that, we get negative 1/2. And that's what we have here. So 2 non-vertical lines are perpendicular if, and this is, I'm going to write down the technical way that the theorem goes, but then we'll also explain it. So the product of their slopes is negative 1. So if we multiply 2 times negative 1/2, we're going to get negative 1. So that's going to happen anytime you have perpendicular lines, non-vertical perpendicular lines, that when you multiply their slopes, you'll get negative 1. The way to test for that is they are opposite reciprocals. And I can't spell today. Reciprocal. Opposite reciprocals. That means they have different signs, because a positive times a negative gives you a negative, and they're reciprocals, so they're flipped. One's flipped upside down. Remember, the reciprocal of 2 would be 1/2. The reciprocal of, say, 1/3 would give you 3. The reciprocal of 4/7 would be 7/4. So reciprocals, you flip the fraction upside down. So change the sign and flip it upside down, and that's how you get your perpendicular slope. And then, just like we had that extra condition for parallel, if you have a vertical line and a horizontal line, then those are going to be perpendicular. And that's because undefined slope is perpendicular to 0 slope. Just as a note, it's been a while since you've seen this, but the upside down T, that is the symbol for perpendicular. So in this statement, we could say that AB is perpendicular to CD. That's our shorthand for writing that. All right, so let's look at some examples of this. Write the equation of the line that is perpendicular to y equals x plus 2. Well, our slope here is 1, because remember there's a 1 in front of the x. Well, if we flip 1 upside down, we get 1, and then change the sign so we get negative 1. So the slope we want to use is negative 1. So negative 4 equals negative 1 times 15 plus b. So then we get negative 4 equals negative 15 plus b. Add 15 to both sides, so we get 11 equals b. So now we're ready to set up our equation. Y equals negative 1x plus 11. And again, we don't put that 1 in front of the x usually, so y equals negative x plus 11. For 2b, just like we did before, we want to determine if the slopes are opposite reciprocals. For the first one, we've already got m equals 4 because it's already in slope-intercept form. For the other one, we will move our x's over, so negative 2y equals negative 8x plus 10. Divide both sides by negative 2, we get y equals 4x minus 5. That slope is also 4. So these lines are not perpendicular, but they are parallel. That's not part of the question, but you should recognize that since their slopes are the same, they are parallel. Now, a rectangle is a quadrilateral that has opposite sides parallel and adjacent sides perpendicular. Adjacent sides are two sides that share a vertex, share a corner. So is quadrilateral ABCD a rectangle? So we need to find the slope of all four sides and make sure opposite sides are parallel and adjacent sides are perpendicular. If that's the case, it's a rectangle. If we find just one situation where that's not a case, it's not a rectangle. It may be some other special shape, but it is not a rectangle. And we'll get more into rectangles in a few weeks. So let's plot all of these. There's A, B, C, and D. And you can probably look at this and tell it's not a rectangle, but we still need to back up that statement with some facts, with some actual calculations. So let's find the slope of each side. Notice here I'm making slope of segment AB because the sides of a quadrilateral don't go on forever. They're line segments. So the slope of AB will be 3 minus 1 over 5 minus 1. So that will be 2/4, which is 1/2. Slope of BC will be 1 minus 3 over 7 minus 5. That will be negative 2 over 2, so that will be negative 1. Now right there, we know that these aren't opposite reciprocals, so we already know that this is not a rectangle. And we could say because 1/2, or let's use some geometry notation, side AB or segment AB is not perpendicular to side BC. And really that's all we need to do, but we're going to go ahead and work the rest of the problem just so you can see the whole process. The slope of CD will be 0 minus 1 over 3 minus 7. It's going to give us negative 1 over negative 4. Negatives cancel out, so we have 1/4. And then our last side is AD. And that will be 0 minus 1 over 3 minus 1. Negative 1 over 2, so that will give us negative 1/2. And you can see here, none of our slopes are the same. So none of our sides can be parallel. None of them are opposite reciprocals, so none of our adjacent sides are perpendicular. But I'll point out what we would want to check. We want to check these two and see if they are parallel. We want to check these two and see if they are parallel. Then we want to check every pair that's together to see if they are perpendicular. So are these two perpendicular? Are these two perpendicular? Are these two perpendicular? And then finally, the first and the last one, are those two perpendicular? So you'd need to check 2 sets of parallel sides and then 4 sets of perpendicular sides. And if all of those work out, then it's a rectangle. However, the first pair didn't work out, so we don't need to go any further. So you may have questions. In fact, you will have questions similar to this in the future. So make sure you know how to check all 6 conditions. So that's it for slopes of parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So do those practice problems, check your work. Please ask if you have questions. Get ready for that mastery check. Good luck.